compiler pass using Haskell and Datalog. Yeah, let's see what we have. I already set up a small project, so well, it's already got quite a lot of files, but there's not that many. The most important ones are, I always have a makefile for when I'm programming, because I can be bothered to remember the commands. And then we have a Haskell project. Oh, there's a rubbish file in there, but it's a Haskell project, so we have a package.yaml and a cabal file. For the rest, it's all in a single source file that we will be working today. And here I had some setup code, but the first thing I'm gonna do is comment it all out and start from scratch. Let me also open a terminal. So at the end I will upload this project to GitHub and put it somewhere in the description when I upload this to YouTube. Let's see. So if I put hello world here again, we should be back to the beginning. Oh. Okay, we got hello world. Let me put on some syntax highlighting that will become more useful later. Okay, so the plan for today is to write a compiler pass using Souffle and Haskell. I've chosen the dead code elimination algorithm. I'm not familiar with it yet, so let's see where we end up at. And also I will be using a really simple language, because that also makes the rest of the algorithm easier, and then we can we can easily go from there and make it more complicated. Okay, let's see. So first off, we need a language. So what I'm gonna do is I'm gonna make a program type, and it's a list of instructions. And an instruction, that's basically either we assign a value to a variable or we will print it out. So let me see. And also put it on the next line. So let's see. So if you want to assign a value to a variable, then we need a variable name and an actual value. And we need types for that. So var name is a string for now, and the value is an integer. Maybe I'm going a little bit overboard on the types, but it reads easier in the end, I think. And not call, but the other thing you can do in our language is with we want to print our variables. Let's save this. Now it's saying that it's defined but not used. So maybe we should first write an interpreter for this to see if it works. So evaluate, program goes in. Let's see. So here we get a list of instructions. Okay. And because it's a list, we can traverse it. And now we need to import traverse. So let me first start up Google. And now we need Brave. And here I'm going to search for traverse. Let's see, data.followable. Okay. So yeah, here we need like a function go, and go, here we have to pattern match on the instructions. So either we have an assignment or we have a print instruction. Okay, and if we see print, then yeah, what we need now is we need like we need to keep track of the state. So let's do that. We need an environment for that. So an environment is a map from var names to values, and now we need to import a map. Okay, and here what I want to do is I want to run this in the state monad. So let's see, we want to modify something. It doesn't know that, we need to import that. So okay, yeah, so what we need to do is we need to find the correct function to so we can go from state t io to just io. So let's go here. I always forget which function I need, so I think it's this one, but it's, yeah, it's eval state t. So a state t goes in, and then a begin state, and then you get the final result out. I think that's the one we need. So eval state t. Let's see. I think I made a mistake. Oh, first the state t goes in, and then, okay. Well, we can flip it around. Yes, and let's start with an empty map. Yeah, it doesn't know what that is right now, but what we need next is we need to put something in a map. So map, let's insert, I think. So a key, a value, and then a map. So the key is the var name and then the value. Oh. Okay, it's starting to work now. So yeah, there's a lot going on, but I will explain it in a second. Oh, and if we want to print it out, what we can do now is first we need to ask for the value. So get, and then we have to look up the var name, and that might fail, but yeah. Let's see. Oh, right. So here we put a show, then that's fixed. And it's complaining there. Strange. So let me put a type signature on Go and see what we're doing wrong. So an instruction goes in, and then we get a state t with an environment, and then the monad is the underlying monad is IO, and then finally we want to return unit. Oh, okay. I need to put a lift here, I think. yes, it's starting to work. Yeah, let me explain it. So basically we go over each of the instructions and we call the function go. But the function go finally returns, or it will return in the end, a result of type state with an environment inside. So we will have access to a state, our environment, and we can modify it, which is what we want. If you assign a variable, or if you assign a value to a variable, we want to update that in our state. And we also want to use IO, so that's why we need state and then IO inside. And the final result is something of type unit. If we come across an assignment instruction, then we have to modify the state and we insert the value, and we do that for a specific variable. And if we come across the print instruction, then we try to look up the variable and then we try to print it. Let's see. Let's make a program. Can't type. So assign x 1, and then we print x, capital letters, and then here we want to say eval program. Okay, it gives us back just 1. So it first assigns the variable x, it assigns the value 1 to it, and then it tries to print it. If we remove this, then it should give us back, it will try to print something that isn't there, so it will print nothing. Okay, that also works. And we can also assign x another variable, then it will print 2, or we can assign the variable y, but we don't print it, so it doesn't output it. But if we put it here, okay, now it works. Let me see. Hey, thanks for following. Where was I? So we can write simple programs now. But we, what I wanted to do was I want to write a compiler pass that says, I think somebody is sending a message. Hang on. Still new to the whole streaming thing. Let me see if the stream is even up and running before I'm talking into the void. Okay. How do I see the chat here? Okay, I see the chat now. Anyway, let's go back to where we were. So what I wanted to do was, if I remove this print y, what I want to do is I want to write a compiler pass that says that this line, this should be deleted because it's that code. Let's see. I messed my Windows setup by looking at the stream. My bad. Okay. In order to do this, we have to add another step. So let's do that. So that code elimination is what it's called normally, but that's a long name. So let's call it the abbreviation, which is DCE. So let's optimize program is, and then we evaluate our optimized program. Now it will say, oh, I don't know this function, and that's correct. And here we want to write a function that goes from program to program. Okay. Oh, and yeah, this won't work because we will need I/O at some point. Why, I will explain later. Okay. Yeah, so here we get our program. Let's call it maybe instructions for now. And what we want to do now is we want to interface with Souffle, which is a data log that makes it really easy to analyze your programs with. So let's do that. That's also the code that I commented here at the bottom. So we can use that. So first we need an import. Then we can say that we want to run Souffle. I think it has 2 parameters, maybe 3. Oh, and it has to be used qualified, the module. Okay. And what we want to do now is we need like a handle data type for our program. So yeah, let's call it that code elimination. And we can give this handle to this function here. And now it says, oh, I don't know instance for this. So let's add it. And I think if I remember correctly, then we have to give it the program facts. Yeah, that's an empty list for now. And a program name. Okay. Yes. Now we can fill in the other hole. Oh, hello, Supi. Or Supipi. Yeah, let me know if I said that correctly, but hello, welcome. I think you're the first person in the chat right now. Let's see, so either we get nothing back here, or we get a handle to our Souffle program. Yeah, let's put a simple error message here that doesn't work. So fail to load Souffle. Oh, and then we have to return the program. Oh, good to know. Let's see. Yeah, if the loading of Souffle goes wrong, then let's just return the original program. And otherwise, yeah, this is the difficult part. Yeah, let's see. What we want to do now is first we want to write the algorithm in Datalog, and then we can add facts from Haskell to Datalog, let it compute which parts of the code are dead, and then we can simplify our program using the results. So yeah. Okay, let me see. Oh yeah, I see it now in the preview. It's actually kind of funny because last time I got the remark from one of my friends who watched the stream afterwards. He was saying, oh, it's covering your screen at the bottom, and now it's covering it at the top. Let me see if I can move it. Better now? Yeah, last time I also had like a kind of different setup. All my output was here, but now with GHE ID, it's all at the top. But hey, you learn from that, right? Let's see. Yeah, so what we need, like, okay, good. Let's see, we want to have like a kind of fact where we define something, so let's add that. Yeah, definitely. I'm still getting used to everything, also with managing the chat and everything, so yeah. But there's only one way to learn it, and that's by doing it, I guess. Let's see. So we need a fact for when we define a variable, and here I also want to have like a line number. A line number is an integer to keep it simple. And now I want to say that our that code elimination, it has a define fact, but also, yeah, we will use our variables at some place, so let's call it use for now. Here again we need a line number and also a variable name. Let's see. Yeah, what we need is we need to add facts for both of those, so let's do that. And I also have to add fact direction. So yeah, we will use define and use as inputs, and we also need another kind of fact in a minute, and that will be our output. Oh, I made a typo here. Okay, now it's saying that we have to add more facts, so more facts, more instances, my bad. Okay, and now we get a very big error message. What's going on here? Is that because we are using type synonyms? Let me try something. So here this is an int and this is a string. No. Oh, okay. Oh, that's because we don't have deriving generic here. And now we need another import, so import GHE generics. That was a bad error message, by the way. Oh, okay. Yeah, now we're making progress again. So the type of line number has to be int32. And here we can use the type synonyms again. Oh, and now it needs int32. Let me see. In which module it is located. So here I see that it's from data.int. Okay, that's better. But we were filling out these instances here. So here we also need deriving generic, and we need to enable this again, and this. So we have our inputs now, but we also need like an output. So we want to know which part is dead. Okay. Here we also need deriving generic. Maybe let's also add a show instance for debugging. And then here we put dead code. Okay. We have to add another instance for that. And we also have to add an instance that it's a fact. This is an output, and yeah, let's call it dead code. Oh, got one place. Okay, it's happy again. And here, what we want to do is we want to go over the program, and we want to, for each instruction. Oh, really? Well, I'm actually not using a Haskell language server right now. I'm using old school GHC ID. I need to spend some time getting HLS up and running, but that's definitely something I want to look into. I also saw that Vlad had like he had it up and running inside Vim. That was really nice. But yeah, I haven't coded Haskell in a while, so I'm a little bit behind on all the setup. Okay. Yeah, well, yeah. If you do happen to know a tutorial for Vim, maybe, yeah, then I can use it. I always try to postpone these things. For now, for these simple examples, it's enough. To have the GHC ID running on the right side. But yeah, I can imagine if once programs start to get bigger, then you want to have auto imports and everything. Yeah. Let's see. So we want to go over each of the instructions. So I guess we need another traverse. Oh, and what we also need is we need like a program, but we also need the line numbers. And for now, we can cheat with zip. So zip, and then do we start at 1 or 0? Let's do 0. Does that work? Okay, that works. Nice. So what this does is it makes tuples, and then we have a line number together with our instruction. Then we want to go over that program, and here we want to call another helper function. How should we call it? Yeah, extract facts maybe. I might get back to you on that. Well, the main reason I use Vim over Emacs is first of all, I'm more used to it, but also I like the startup time of Vim, but yeah, that's probably because when I tried to use Emacs, I used way too many plugins. So yeah, but maybe it's better now, and maybe you have a way of making Emacs start up quicker. But yeah, I like a good editor setup, but configuring it is it's the absolute worst. So I try to postpone it as much as possible. Let's see. So here, let's add this helper function. Oh, nice. Okay, well, Let's talk after the stream then. Where was I? So first we extract all the facts. Am I saying that correctly? Wait, let me see. So here we do a pattern match again. So either we have the assignment instruction, or we have the print instruction. Whoa, it's not happy now. Oh, right, okay. Yeah, we can't use lambda case here because we get the line number as well as the instruction. Let me shorten it a little bit. Okay, that's a little better. So here what we want to say is add a fact. Oh, and we want to add use, and it's a line number. I think that's fine. And here we want to add a fact. Define let me put it like this so it's it doesn't go off the screen. Okay, so what we did here is first we add all the facts, and then we have to run it. Still happy about that. And now we want to get all the results out. So that instructions, I guess we can call it. Souffle get facts. Okay, and now what we need to do is yeah, we need to add another helper function. And okay, it's complaining that we don't have it now. So here we will get a list for dead instructions and our original program. Let's see. If I do this, yeah, that will work out better. Okay, yeah, I think we need to add a type annotation. So here we have a list of dead codes, and then we have, yeah, it's not a program, but we have a list of line numbers with instructions. And what we get out is a program again. Okay, it's happy again. And we had to add the type annotation because otherwise this function doesn't know what it has to do. Yeah, okay. So, and that code, if you remember, there we just have the line number inside. And here we have the line number. So, if we should go over the list of instructions, and if the line number is inside the dead code part, then we remove it. Yeah, basically. So let's see. Let's see. That line numbers is, yeah, I'm gonna write it down in a really stupid way and then refactor it. So I think it's like this. I almost never use list comprehensions, so bear with me. Okay, it's happy about that. So we have it unpacked now, and then filter of a program. Oh, yeah, and that won't type check because we only need to have the second part, so we need to do map second. Okay, and now we have a function. So, okay, here we have the line number and then instruction. So if the line number is not an element of that line numbers, this is absolutely hideous Haskell code, but let's refactor it in a minute. Okay, so the instruction is not that important there. Ooh, yeah, nice. But I think we need first then also. But that's a good suggestion. Let's see, so like that. I made a mistake. Is it because it has to be like this? Yes. Okay. Yeah, I'm not sure if this is more readable, but let's go with it. Okay, so what did we do? So we have the algorithm now. It's yeah, we write down all the facts that we see, and we can simplify it at the end. But oh yeah, if we run it like this, yeah, it will fail. So let's first fix the warnings, and then yeah, it should fail because it won't find the Datalog program. We haven't written it yet. Wait, that's strange. Oh, it's shadowing. Ah, that's not nice. Can we do this? Is that in scope here? That's not in scope. Okay, then we need a better name. So yeah, let's call it instructions then, I guess. Or I think we can, not sure how readable this will become. Yeah, that compiles, and what we see is it fails to load Souffle. And yeah, because it fails, it returns the original instructions. Line 38. Oh, right, because yeah. Yeah, what we can do maybe is we can create a bunch of scenarios, and then we do a for loop over each of them, and then we have like a poor man's test suite. Well, we could do like a simple test suite. That's also possible. But let's do this approach first. And then we need another layer of lists. So like this. And then here I used program. Wait. Oh wow, it was. Oh wait, this is commented code. Let me remove all that because it's not used anyway. And here we should go like 4 scenarios. And then, oh well, this is basically a program. Line 85. Why is it complaining here? Because this is instructions now. Yeah, now it works. Okay, but it says failed to load Souffle, and that's because we don't have the Datalog file yet. But let's try to write it directly in Haskell. And then we need another import. Oh boy. Yeah, I don't want that right now. And also var. Oh, that's bad. Yeah, I need to fix that. Where do we have var? 192. Okay, this is better. Oh, yeah, I'm not used yet to looking at the chat all the time, so maybe there's a delay just from the chat, but then there's also the delay from me, so... yeah, my program also would have worked, but what I want to do in the end is like multiple... I want to simplify multiple programs. So I could have called it scenarios or programs or my programs. Yeah, naming things, it's hard. Let's see. So we need to change this function here, but I don't know the signature off the top of my head anymore. I think, yeah. Okay, so how do we call that? Let's call it algorithm. Yeah, it's kind of complicated. And this has this type. I'm basically reading this from the error message. Okay. So what we want now is we want a predicate for define. And also one for use. And one for that code. Oh, yeah, now we need to add extra instances. Yeah, this is a little bit boilerplatey, but once you get over the initial boilerplate, then it's super smooth. Okay, so now comes the hard part, but let's start simple. So maybe I should move this algorithm down a little bit, or move it to the scenarios part so that I can easily go back and forth. So I have to admit I'm not used to writing an algorithm like this yet, so let's figure it out together. Basically what I want to say is here it's being used and here it's being defined. But this is only being defined and it's not used, so that's dead code. So let's write that down. So dead code, and it has a line number. So it's dead if we define, I need to add variables, by the way. I'm thinking too much already in Datalog terms. So we need a line number, but we also need like a var name variable. Yes, you're right, but that's going to be the second scenario. But you're thinking along quite nicely. Let's see. So where is our define thingy? Okay, so it has a line number and a variable name. And if we don't have a Yeah, you're right. Hang on. Let me first write this part, because I know how I should write down this. This is wrong. Okay, it compiles, but this has to be negated. And I don't know how I called this in my DSL. But Hubble is really nice here. Let's see, so is it negate? Oh, it's not with a prime. Now it says nothing. That's strange. Let's see, what is the optimized program? Okay, we need to add a deriving show here. Okay. I think it removed the assign instruction to one too many. Why did it do that? Oh, I think we need. I think we need two variables with line numbers. So yeah, at least we won't have mutable state. So oh, I really can't type today. So something is dead code, and I think it's like this. So if we define something at a certain line number, and we don't use the same variable at another line number, and we have an exception now, that's probably let's see, it's probably because a variable is not grounded. And yeah, that's something I need to fix. That's like, it's a type error if you run it with just Souffle. But in my DSL, it's not caught yet. Oh, and now I get this strange error. So basically, double underscore is what underscore is in Datalog. And that's, yeah, it's giving that strange error because it can't define, or it can't figure out the type for this anymore. Okay. Okay. So I think we're getting closer. So what this is saying is, if we define a variable at a certain line number, but we don't use the variable at another line number, we're not interested in the second line number, then the assignment then the assignment at this line number is dead code. And I mean, like, it's only 3 lines of code. It's like, super easy. But of course, it doesn't capture all the cases. So let's see how far we can push this. Oh, my Vim bindings are a little messed up. But let's see. So if I put, okay, indent is also really weird. In the second case, it should keep the entire program. And it does. Okay, what's another scenario? You had one earlier, so assign first x to one value and then another. And now this one should be deleted, right? And what we are seeing now is that it's not smart enough. Okay, yes, I can do that, because yeah, it is already becoming quite a lot of code. So let's go all the way back to the beginning. So what I did was, first I created some types. I created a simple language with instructions, so we either can assign a value to a variable, or we can print it out. And that's, I think the simplest program that we can optimize. But yeah, I might be wrong there. And then I added a simple evaluator just to see if it was if the behavior stays correct before and after evaluating it. That's mostly for debugging, but now that I think of it, that's also a good place for property-based testing. But anyway, we have our types, we have a simple evaluator. Then we have some scenarios here. And what I did now was I defined some types for our Datalog algorithm. So what's important is we have to know when a variable is defined. We have to know when a variable is used. And with those two things, you can figure out which parts are dead code. And for that, you also need like a kind of result data type. The way Souffle Haskell works is we need like a handle data type. That's this dead code elimination data type. And then we can attach information to it. So here we say that the program has three kinds of facts. So define, use, and dead code. And then we have to write down for each of the facts what it is or how it will be used. So define and use, those are input facts. So we will be giving that information to Souffle. And with that information, we can figure out which parts are dead code. And then we have to extract that from Souffle back into Haskell. And that's why it's an output fact. For each of those, we have to say what the fact looks like in Datalog. It's like a mapping back and forth between Haskell and Datalog. We add some instances to serialize and deserialize it back and forth between the two languages. And what I did then is we have all those data types now. Now we can write an algorithm, and I used DSL for this. And then you can easily ask, give me predicates for all these kinds of facts. And then you have to introduce some variables. In Datalog that's automatically, but here in Haskell we have to do it manually. And now we have predicates, we have variables, and now we can stitch them together using monad syntax. So here, this is this is the full algorithm for now, but it will become larger later. And this is saying, this is the algorithm that I went over before. So if a variable is defined but not used, then it's dead code. So we have the algorithm now, and we have we have like a description of the Datalog program. So now we can use run Souffle interpreted. And what that does is, you give it the handle for our Datalog program and the algorithm it should run. And it will render, the algorithm defined at the top of the file. That's still like an AST of some sort in Haskell, but it first has to be converted to Datalog. That's written to a file, and then we evaluate it immediately. And here, we have to do like a pattern match on this. The last part of this function is a lambda, because loading Souffle can go wrong if it can't find the Souffle interpreter. And if it fails, then you have to handle the error. But if it works, then you can do your algorithm. And what we did was we annotated our program with line numbers, basically. And then we made a helper function called extract facts, and that basically goes over each of the instructions one by one. And for each of those instructions, we write down a bunch of facts. We do that for the entire program. So all the facts are now on the Souffle side, but it's not automatically computed. You have to start it manually. So that's why you do souffle.run. Then it does a lot of number crunching. And then we can get the results back out. And then, yeah, with the results, you still have to do some processing on the Haskell side, and that's the simplify function. And that's it, basically. But yeah, that's all in like a little more than 100 lines of code. So that's, yeah, kind of crazy. So yeah, we were adding more cases and figuring out where our algorithm breaks, and this is one of them. So yeah, because our program is really simple from top to bottom, then we also have that code if we have 2 assignments in a row. So if we have, yeah, let's see. So we have a define at a certain line number, and we have another define of the same variable. And now I'm thinking, is this enough? But let's be sure. What we need to do is we have to add another line number variable. And so now what I'm saying is there's 2 different kind of line numbers. And if line number 1 is smaller than line number 2, let me see. Yeah, I think it works. Because, what I'm saying is, so there's an assignment or the definition of a variable at a certain line, and there's another definition at another line, but the first line number is smaller than the second line number, then the smallest line number is, that's that code then. Yeah, it blows my mind as well that it's this short, but that I think maybe it's a little unfair because our language is too simple, but still it's this is powerful. So if we add, oh my bad, there's something going on when I try to paste code. Need to look into that later. So if I do this, then what I want to see is this should be deleted. And it works. Okay, that's nice. Yeah, wow. Took me less than an hour, and does this cover all the cases? I think so. Oh no, maybe it doesn't, because what we can do is, if we have an assignment here, then an assignment here, then a print here, then nothing should happen. But if you do this, then only that line should be deleted. Oh yeah, I think so as well. And also this seems like, I think this is also, in a way less complicated than list comprehensions, but I'm not sure on that, but I think this scales up better. Like this is simple enough for list comprehensions, but if you have a real AST, then it might become a lot more complicated. But let's see, this, what we have here is, how do we write this down? So we have a definition here, then we have a use, and then here you have, I think this is another case, maybe. Yeah, the hardest part is figuring out a pattern to match with this. Let's see. So we have a use, and the use is is before all the defines. Can we use that? Yeah, well, I think that's, yeah. I'm not sure. Well, what we can try is yeah, it's this is a difficult one, because if we write down, yeah, maybe I should write it out what I'm thinking. That's, I think, easier to explain. Let's say if we have a use and then you do not, I don't think you can do that. You can only another refinement. What do you mean by that? So add like another case here, or make this larger, because if we add a case here, then we will be only able to remove more code, and because we are adding more situations where we find that code. So yeah, the more situations you add, the more that code it finds, so it makes it smaller. So that gives me the intuition that we should add stuff here and make it more stricter inside this body, so it can tackle that use case. Because if you add it in the body, then it becomes more strict, so that code will filter out less less instructions. But yeah, I'm figuring out how. You can't just put a use in between here, because then it won't work anymore for this use case, for example, because it won't find a use. That's not easy. But what I wanted to do is, I want like, it should start all over again, right? So, yeah, not easy. Is there another way to think of this? Let me see. I think what we need to do is we have to add like some kind of construct saying we go from here to here, but that might make it a lot more complicated. Yeah, that's a good question. Let me look at the Souffle docs, but I don't think that's possible. If you don't want it to occur, you just don't write it. But yeah, let me check to be certain. This is also why I want to actually use my library. Up to now I only did the simple examples, but now you start to see how it really works. Let's see. Where could I? Here under language. Then relations, I think. No, relations is the type of relations. That's more something performance related. Well, I do remember that. I think it's in the examples. And yeah, I think it's this one. So you can see here it also has a define use, and then yeah, it's like a chain, because in our example we have a chain going from here to the print, and then a chain from this assign to this print. And what we don't have right now is those chains. We want to say the chain stops here. And yeah. So let's see what it's doing here. Yeah. So you have like a read and a write that's basically define and use, but it also has like a successor kind of predicate. And here it's saying that it's using these variables. I think read is use, and here it's defining some variables, and here it's saying that which statements come after another. Yeah, I don't think there's an example here somewhere, or is it this one maybe? Anyway, you have a chain. Yeah, this is just saying, oh, this statement follows this one, this follows this one. And that's, yeah, then you are building like edges in your program. And what you can do then is you can build a flow. Yeah, you could do that, I think. But yeah, no, that won't work, because what we have already is filtering out too much. But let me go over this algorithm on the right side. So I think we need something like this. So this is basically, we write down define and use. That's also what we have. But what this algorithm is doing extra is it's saying which steps follow one another in the program. That's really easy for us because it goes from 0 to 1, 1 to 2, and so on. And what you can do then is you can describe the flow. And here it's saying you have a flow from one to the other. If you have a direct successor, or if you have a third point in between. So that's basically building up your chain. And then it says if you have a variable x and it's written at one point and read at another point, and you have a flow between reading and writing. Yeah. So if you can write down this flow thing, then you have it. But the difficult part is, yeah. Oh, that's difficult. Yeah, it's too bad that the example doesn't show what this all means. Wait. What we can do is we can say that after print you have a new start for a variable. Is that an ID? but yeah, maybe you don't have a start. I'm not sure I understand completely. Oh. Hang on a minute. Hey, that actually makes me wonder, can't we just write this down anyway? Because we have it here. Oh my god, I'm so stupid. So if we have this, then we have another line number. So here we have to say, well, let's make this line number 3. And then we have to say that line I wonder if this is possible. So line number is smaller and 3 is smaller than 2. Oh. Yeah, but this doesn't work. That's the problem. And that's probably because of this here. This line number 3. That's an... Yeah. Let me... what I can do here is I can do this. And then... Oh, I need to indent all this then. And render IO. Oh. So here, let's write it down. Okay, and what we can do now is we can yeah, that's one way to find the mistake. But basically, if you use a negation, then all the line numbers have to be grounded. And what that means is you have to use them somewhere else in the body of a relation without a negation. And what we can do is we can say that it's a line number. I'm not sure if this is the best way to approach it, but let's try it. So line of code, I guess we can call it. And here we have a line number, and yeah, we don't need the show instance. Okay, and now it's complaining. Yeah, my copy shortcut in Vim is broken, I think. So, line of code is an input. Okay, we have to add a Marshall. Okay, it's happy again. Well, where is our algorithm? So here we have to say okay, here we don't have to know that it's a line of code, but here we can say for, and this is the nice part about metaprogramming. Here we can say, oh, I'm doing too many steps at once. So first we need a predicate, line of code. And here we want line number 2, and line number 3. draw lines of code. Oh. Did I make a mistake? Oh. Camel case. Okay, now it's I have to go back to the program instance. You have to say that's a fact of the program. Yeah, it's being a little strict, but that's fine, I guess. And it's not smart enough yet. Well, actually, we made it more stupid because it's not filtering out some of them. Here we get the full program back now. But what we can do now is we can say traverse and then souffle.add fact of program. Let's see. So first we get out the line numbers again, and then for each one of those we want to say add line of code to the list of facts. And now it's doing something else. So here we see, if we go back to the example, so we have this, we don't have this. We don't have this, but we do have this, this, and this. Okay, I think we have a logical error somewhere. So what we're saying is why is it deleting the first assignment? That's strange. What we're saying is we have a definition at a certain line, and we don't have. Oh, is it maybe no. I was thinking maybe it was related to less than or equal, but all the lines of code are different. But yeah, I'm saying line number is smaller than line number 2, so this one is smaller than this one. And I'm saying line number is smaller than line number 3, yes, and line number 3 is smaller than line number 2. That should also be correct. Why is it saying that? Why is it saying that this is dead code? And why is it not saying that that is dead code? I have a feeling that this is not the way to go, but I don't know the real way to do it then, or at least not yet. So what's going on here is we have a define, And here we have another define, but no use in between. Oh. I really don't know. Maybe we should go over the other examples and see if they are all broken or if it's just a complicated case. So here we have assign x1 and print x. That's good. And here we have, yeah, both, so nothing should be deleted. And then there, yeah, this one is already broken. So I think we broke the rule that 2 assignments in a row, it doesn't see anymore that yeah, this one is, yeah, dead code. But why? But let's continue, and here this one, oh, that's interesting. Here it knows that 2 and 3 are not dead codes, but 1 is. It's funny how it went from super fast and quick iterations to this. Hello, welcome to the stream. Yeah, I'm doing great. We have a difficult problem right now, but I'm having a lot of fun. And you? Good to hear. Do we have 3 lines that work for this rule? Three lines, 2 for defines and 1 that is not in use. Okay, so isn't that this example? The top one? The top one works. And then we have this example. Oh. And yeah, this one doesn't work anymore. So our simple definition was working better than what we have now. I'm thinking there's another way, like if we see that we have no wow, this is really complicated now, but like if we can have a way to say that here we have a start of a new chain, should we not say like maybe we need to say that there is a use and then an assignment, and that's not that code. There are no 3 lines such that this one will work. I'm thinking we made it way too complicated. Should we not say if we have a use and then two defines? Oh no, Basically the way it works is, yeah, I think so too. But the way we should write it down is like, we see something about the program and we should translate that into facts, and if we can then use those facts to make a query in Datalog, then we have it. But I don't have a good way of saying that it's, yeah. Basically you have two groups, so you have assign and print, and then here you have assign and up until this print. So but we know after a use. So let's delete some code. Just go back to what we had. So we had this. We'll get rid of the ugly error message. Now it's removing way too much. Line number should be less than line number 2, right? So now what we have is it removes this one, but it also removes that one because this line number is smaller than this one. Okay, but I don't know a good way to write that down. So the first one, we have step 1 basically, but now we have to create something to say that there's a print in between. Oh, okay. I think I'm understanding what you're saying. So leave this as a helper kind of function or predicate, and then add another one and say that everything except for just remove the not before use. But do you mean that we should remove this not then, or wait. Yeah, I think I understand what you're saying, but that's probably not the way to go in Datalog. Well, I think it can work. Oh, right. Yeah. I think that can work, but it's probably not as efficient as it could be. So what you often see is that you have something like this, and that's, yeah, it can expand, and then yeah, that would be the bad instances, okay? And then you could say, oh, that code is everything, all the candidates minus this one. And then you would have it. Yeah, I think that works. So I can do that, but yeah, let's go a few steps back. So this, and now we don't need this anymore because that was kind of ugly. Oh, and now it's complaining about all these things. Get rid of that. Okay, so what you are saying is like that. Well, bad instances is basically in use. But anyway, let's go with it. And that's an input. And now we have to add one of these. Okay, go back to the algorithm. Okay, no new messages. Let's see. So what you are saying now is that this is like a bad instance then? Yeah, it's a GHG ID. So what I did was I did vertical split in Vim with VSP, and then I went to the correct folder, and then I did this command, which is GHG ID, and then I tell it to run cabal on this project, and each time it succeeds it should run the main function, which is defined in the same file I have open, and that's all you need to do. And then it will run this function every time that it compiles, and otherwise it will give you the messages. Oh boy, wait, like this. I think I can put it in the chat. I wonder how it will show up because I'm sending it via a bot. Oh, I have to log in. And I lost all my history. Great. Oh, I can't seem to log in. That's not great. Can I do it directly in Twitch? There you go. Oh, somehow... Yeah, remove the space in between main and then it will work. Yeah, that's because I have a new line here at the end. Somehow it added that. Okay. So what you were saying, Supi, was this. So we have two defines, and it's not a bad instance. Don't know what you mean by that, but yes, it's running in a Vim terminal. Yeah. What do we add here? Like, if we have two defines. Oh yeah. Okay. So in this case, this code would be alive. So the first define is alive. So here we should say line number. Oh my god, it works. But that's not the efficient way to do it. I think this works for the simple use case, but I don't think it's idiomatic data log. Yeah, basically, yeah. What we're saying is you have two use cases or two definitions, and one definition is before the other one, but it's not in the set of bad instances. Okay. Yeah, nice one, Soupy. Yeah, maybe that's something I need to figure out for next time. How to do it in a more elegant way. But I don't think I can figure it out on stream. I need to have... maybe I need to sleep on it sometime. But yeah, we did quite a lot actually in like 90 minutes. We can optimize all these programs. So, oh, let me first, before I claim that, let me check. So here it removes the y, because yeah, that's this case. And here it keeps everything, and then it keeps that one. Yeah, that case is also correct, and that one also. Wow, nice. Parsing. No, I haven't done that yet. That's maybe also for another time. Well, what I really want to do is, this was like a warming up exercise. So it's a really simple language. And yeah, you can write yeah, the most basic compiler algorithms for it. Just to get a feel of Haskell combined with Datalog, but what I really want to do is I want to write my own Datalog, and I know Soupy has his own variant already, but I want to have my variant also, and I want to have all the algorithms in Souffle at first. Yeah, do it. I can upload this code later. But what I was saying was I want to have my own Datalog variant, and in the compiler for that Datalog I want to use these kinds of algorithms. Yes. and then if that all works, then once I have the Datalog, then I can use it myself in my own compiler, and I guess that's the Datalog version of bootstrapping. And yeah, then we can also do many more exciting things like the parsing, but also we can use LLVM to compile it to really efficient, really efficient code. So yeah, there's a lot of ideas I still have, and this was like a good warming up exercise. And I will think on how to do this in a more elegant way, so we can get rid of this bad instances workaround, because I don't think that's the way to go. Don't think it would scale up nicely. And I think we need more like an inductive kind of definition. Like if you have that code and something else, then yeah, I have a Datalog I want to build, like complete with parser and everything, and also compile it down to LLVM. I used to have another language, but it was more Haskell-like, and it was also way too big. And yeah, I had the parser and the type system working, and yeah, then I basically stranded there. And the approach I want to do now is I want to have a really simple language, and Datalog is already really simple, but I want to make that Datalog even simpler. So at the beginning, it will have only integers, for example. Yes, it's in the same family. It's a logic programming language. But yeah, what I want to have a really stripped down data log, and then I want to go all the way from the beginning to the end. So parsing and then semantic analysis and all those things. Type system won't be needed if you only have integers. And then you have the actual engine, and that engine that could be done with LLVM maybe. And once you have that, then you can iterate on it and start adding more and more features. That's my plan to do in the live stream. Yeah, but that's gonna take me many sessions. And also Count Oren. Yeah, Datalog is really nice in this case because it's like a really easy way to. Yeah, I want to have it typed, but Datalog is really nice to have to create queries. And then if you go over your program, if you walk over the abstract syntax tree, then you can easily write down facts. And with those facts, you can then later on make queries on them. And it's a really elegant way of thinking. And yeah, it feels very natural. And yeah, and on top of that, it's also super fast if you use Souffle. So yeah. That's the reason I started writing the library, but now that I have the library, I want to actually use it. But yeah, I think for today it's enough. I'm starting to notice that I'm becoming a bit more slow and it's difficult to reason about the code. So let me do some more digging on how to write this down, and then maybe I will show the result in the next stream or something. Yeah. Yeah, so Datalog is, you can view it as like, yeah, it's a query language like SQL. Oh yeah, you basically explained it for me already. SQL is typed, yes. But Datalog can also be typed. So for example, in Souffle you can't mix and match integers with symbols, which are strings basically, because that wouldn't really make a lot of sense. And yeah, it's the same is true in SQL. But the nice thing about Datalog is you can make really easy joins. Like, yeah, do I have a good example of that? But basically, each time you have a new fact, you have to maybe make a jump between tables if you wanted to do it in SQL. And in Datalog, it's yeah, it's really straightforward. You don't even think about it. Yeah. But yeah, let me create a repository for this. And then I will slowly close off this stream because I'm starting to get a little bit tired. Yes, that's also true. And Datalog automatically finds all the facts, and you can, with recursion, you can write down your queries really in a really short way, and it will automatically expand it until it finds no more no more other facts. Let's see. How do I? Playground. Yep. Create. Yeah, you're welcome. It was also interesting for me. Um, Phew. Oh, good questions. I don't think you can think about it in like a tail recursive kind of way. I think, but yeah, I might be wrong here. But after it's done optimizing it, it's gives you like a really efficient loop. So it optimizes it away. But yeah, is it tail call optimization? I'm not sure. So it can either be one loop or two loops or even more, depends on what you wrote down, but in the end it's all just loops. And that's also why LLVM is probably a great fit for this, because yeah, in C you also have loops and LLVM is good at optimizing C, so it's probably also good at optimizing this. And about the recursion being limited, yeah, I'm not sure if it's Turing incomplete because of that. I would have to look that up, but yeah, it's powerful. That's for sure. So add that code elimination. Can't type anymore. Oh, I should have done that on a branch maybe. Okay. Incremental queries, not yet, but they're working on it. So there's like a Zulip chat for Souffle if you go to the repository. And yeah, at one point somebody was asking basically the same question, but they're working on incremental queries. But yeah, the way it is right now, you have to run it all the way from the start all over again. But yeah, it's a good thing it's fast. So yeah, what I want now is I pushed it on a separate branch, but I want to keep my master kind of clean. So let's see what's in here. Oh yeah. So that we can do an experiment each time in the same repository. Yeah. Let's see. I need to repaste it, I think. And then remove this one because we have it on the other branch. Oh. Okay. So if I refresh it now, I need to make master default, but yeah, it's all uploaded now. Yeah, optimizations can be kind of tricky sometimes. Yeah, so I uploaded it to GitHub. I will try to think of a more elegant solution during the rest of the week. But for now, I think we'll leave it at this. And yeah, thank you guys for coming. And yeah, see you next time.